So let's have a look at the distance formula. What I want to do is on this graph right here, so you see how we have these 2 points. We've got x1, y1, and we've got x2, y2. I want to show you how that's connected to this formula right here. So if I were to take this and extend and create a right-angled triangle from here, so there's my right-angled triangle. And how would I be able to figure out this length here? This is going to be x2 minus x1. And this distance right here is y2 minus y1. What I want to do is I want to figure out this length right here. And in this formula, that's what refers to the distance. Okay? So if we're thinking back, we can relate this to the Pythagorean's theorem, right? Which is c squared equals a squared plus b squared. Now I could say that this is the a and this is the b. So then this becomes the c. So now instead of writing a, I can write x2 minus x1 squared. And then instead of writing the b, I can write y2 minus y1 squared. We add those and we square root it. And that gives us the distance formula. So it comes directly from a squared plus b squared equals c squared. Directly from Pythagoras. Okay. All right. So if we're looking at these 2 points here, we want to find the distance between these 2 points. So I've plotted them already. So this is 4, 1, and this is 5, 2. And I want to find that diagonal. So basically we've got a square, right? I've got these points on the corner, and I want to find that length. Well, the distance between here and here is 1, and the distance between here and here is 1. And so we think that that's probably going to be square root 2. Okay, our answer. So let's use our points and our formula to see if that works. So this is our formula here. Square root, and we've got x squared minus x1 squared plus y2 minus y1 squared. So then I've got 5 minus 4 squared plus 2 minus 1 squared. And I end up with 1 squared plus 1 squared, and that equals square root of 2. So my distance between T and R is square root 2. Okay, so let's have a look at this next example. Let's plot these 2 points. So I've got -3 and -5. That's right here. And then I've got -4 and 6. That's right up here. So I'm going to connect these two with a line. All right, so I need to find the distance between those 2 points. So using my formula, square root, we've got difference of the x's, which is -3 minus -4 squared. Excuse me. -5 minus 6 squared. And this is going to be -3 plus 4. So what does that give me? 1. and this is going to give me negative 11. Okay, square each of them, and then add them together, and square root it. Square root of 122. Okay, so that's my distance. Now, I want you guys to make a connection between this step here and the graph. Can you visually link these numbers to something that's happening on this graph right here? So this is what? The difference of x's. So if we look at the difference of the x's, what do we see right here? We see that there's a difference of 1. And what is this here? This is the difference between the y's. So what do we see as the difference between the y values? So if I were to count from here all the way up to here, how many units do I go? 11. Okay? So there's the direct connection to this part of the formula right here, to this part of our step, just to see if we're visually connecting this to this, to make sure we're on the right track. Okay? All right. Okay, that's pretty much your distance formula. Okay? And one little note, when two segments have the same length, they're said to be congruent. So that means they have the same measure. All right? And then there's some notation things here. We write line segment AB is congruent to line segment BC. Okay? And that's just what this notation means. This means right here, has the same measure. All right? Okay, so that's basically it for distance formula. Not much to it.